Hello, everyone. Thank you for joining today's webinar on implementing basic access control functions with the BioStar 2 Device SDK. Today, I'll walk you through how to configure and implement a basic access control system using the BioStar 2 Device SDK. Before we get started, you might wonder how to find our webinar contents. There are two ways to access them. First, you can visit the Suprema YouTube channel. We will post the recorded video to this site. You can find the link on the slide or simply Google Suprema YouTube. Second, you can visit the Suprema technical support site. You can find the information along with a Q&A list on this website. You can find the link on the slide. Please search Suprema webinar in the support page or simply Google it. Here's what we'll cover today. We'll start with a brief introduction, then move on to preparation, setting up the environment, and building. After that, we'll look at the core components of access control, followed by an API walkthrough, going from door to enroll user step by step. And finally, we'll wrap up with a demo to see everything in action. Let's get started. First up, introduction. Let me start by explaining the purpose of this session. This session is designed to help developers set up an access control using the BioStar 2 Device SDK. To get the most out of today's session, we recommend the following. First, having a basic knowledge of C# is helpful, as all our example code is written in C#. Second, basic experience using the BioStar 2 Device SDK in a BS demo will make it much easier to follow along. But don't worry if you're new to this. I'll explain everything step by step so everyone can understand. Today's session is designed for developers who want to build basic access control configurations using the BioStar 2 Device SDK. All right, let me give you a quick overview of what we're building today. Our goal is to understand the access control flow using the BioStar 2 Device SDK. We'll go through 4 key steps. First, configure the device, connecting and initializing the device. Then, define rules, setting up doors, schedules, access levels, and access groups. Next, enroll user, registering users with their credentials and assigning the user to an access group. And finally, verify, checking if the user can access the door. Below, you can see the scenario we'll work through together. We'll create a door, set up access levels and groups, and enroll a user with credentials. Now let's move on to preparation, setting up the environment, and build. Here's the development environment we'll be using today. For the IDE, we're using Visual Studio 2022, and the language will be C#. On the SDK side, we'll work with BioStar 2 Device SDK, version 2.9.9. And for the device, we have a BioStation 3 running firmware version 1.4.1. If you haven't installed the BioStar 2 Device SDK yet, you can go to the official documentation and click View BioStar 2 Device SDK on GitHub. From there, you can download the latest version. Additionally, before we begin, I highly recommend reviewing the official documentation. It covers the pre-build setup, API references, and everything you need to get started. The link is located at the bottom. Please keep it handy for reference. You'll find it helpful throughout your development. All right, now let's dive into the core components of access control with the BioStar 2 Device SDK. This section breaks down the key building blocks you need to understand. To understand an access control system, there are 3 fundamental questions: where, when, and who. These 3 questions form the foundation of the Suprema access control system. Where refers to the door or resource being accessed. When refers to the schedule during which access is permitted. And who refers to the person trying to enter. In other words, access control determines who can access where and when, based on these 3 key elements. In the Suprema system, we connect these concepts through the door, schedule, and user features. In Suprema's access control, components are organized in the flow you see here. We start with the door, which represents where a user can access, and the schedule, which defines when access is allowed. These 2 are combined into an access level, which defines which door can be accessed and during what time. Next, we have an access group, which brings together access levels and users. By assigning users to access groups, the system can clearly define who can access where and when in a consistent manner across all devices. Let's start with the first component, where. This represents the door, the physical location or resource that users will access. Here's what makes up a door in the access control system. As you can see, a door consists of several components. The door sensor, which detects whether the door is open or closed, the exit button, which allows users to open the door from the inside, the reader, which is the device that authenticates the user, and the door lock, which physically locks and unlocks the door. When you configure a door in code, you'll set up the door lock, reader, door sensor, and exit button. In Suprema, typically only the door lock and reader are required. Door sensor and exit button are optional depending on your setup. Next up, when. This represents the schedule defining when access is allowed or denied. So what is a schedule? A schedule defines the days and time ranges when access is allowed. For example, you can allow access only on weekdays from 6 a.m. to 6 p.m. or block weekends entirely. By combining a door with a schedule, you can create an access level that defines where and when access is permitted. Let's look at a few examples. Door A uses the always schedule, so it can be accessed anytime, 24/7. Door B allows access from 12 a.m. to 6 a.m., so it's only accessible during the early morning hours. Door C allows access from 6 a.m. to 6 p.m. If the current time is 5 p.m., then Door A and Door C would allow access, but Door B would not. We've covered where and when. Now let's look at who, the user. In terms of code flow, we typically create an access group first and then assign it when creating a user. But for the sake of explanation, I'll cover the user first. On the left, you can view the basic user information, including user ID, name, and the start and end date. On the right, we have credentials, which are the methods used to authenticate the user. A user ID is a unique identifier assigned to the user. Suprema face credentials are divided into two types: face and visual face. The face credential is enrolled using images captured exclusively with an infrared IR camera and is supported only on FaceStation 2 and FaceLight devices. The visual face credential uses images captured by a visual RGB camera for user authentication and is supported on Suprema's latest face authentication devices, including FaceStation F2, BioStation 3, and BioEntry W3. The card uses a card, such as a CSN card or a Wiegand card. PIN is a numeric password. Barcode and QR code use scannable codes for authentication. Please note that supported credentials vary depending on the device and its configuration. Now, let's examine how access groups tie everything together. An access group links users to access levels, defining who can access which doors and when. Let's walk through these examples. In the first row, access group A includes user A. The assigned access level is Door A with the always schedule, so user A can access Door A at any time. In the second row, it's the same access group and user, but the user is attempting to access Door B. Since Door B is not included in the assigned access level, user A cannot access Door B. In the third row, access group B includes user B. The assigned access level includes Door A and Door B, both with the always schedule, so user B can access both doors at any time. Once access groups are configured this way, the core access control setup in Suprema is in place. Now that we understand the core components, let's examine how they are implemented in code using the BioStar 2 Device SDK. We'll walk through the API walkthrough. Here's the overall program flow. When working with the BioStar 2 Device SDK, typically you initialize the SDK, connect to a device, configure access control, and then release resources when you're done. Today, we'll focus on the access control part, which includes creating a door, access level, access group, and user. I won't cover the initialize, connect, or release steps in detail here, but you can find them in the official documentation and the BS demo. Before we dive into each step, Let me show you how I organize the demo sample code for this webinar. In the run function, I call 4 functions in order: create door, create access level, create access group, and create user. Each function handles the structure setup and makes the API call. For example, create door fills the bs2 door struct and calls bs2 set door. Now let's look at each function in detail, starting with create door. Let's start with step 1, creating a door. First, we define the door settings in code. This includes the entry device ID, lock relay, door sensor, and exit button. Next, we populate a bs2 door struct with these values. This struct contains the full door configuration, including relay port and input ports mappings, lock options, and related settings. Finally, we call bs2 set door to send the configuration to the device. For more details on bs2 set door, please refer to the official documentation linked below. If you've used BioStar 2 before, this might look familiar. On the left is the door configuration screen in BioStar 2. On the right is the bs2 door struct in the SDK. Largely, configuring a door in the BioStar 2 UI is the same as populating the bs2 door struct in code. So if you understand the UI, you already understand what the SDK is doing behind the scenes. Now, let's examine the bs2 set door API. This API configures a logical door on the device. But what does that actually mean? The device itself features physical ports, including relay port and input ports. bs2 set door tells the device how to map those ports to door components. For example, a relay port can be used to control the door lock, which physically locks and unlocks the door. Input ports can be used for the door sensor and the exit button. Once you call this API with a bs2 door struct, the device knows how to control the door. If the configuration is successful, the API returns a success code. In short, you're sending the door configuration to the device, and from that point on, the device can send control signals to the physical door based on your settings. Now we move on to step 2, creating an access level. This is where doors are paired with schedules. On the left, we have door ID 1 and schedule ID 1, which means always. These are combined into a bs2 access level struct. Inside, you can see a bs2 door schedule struct, which ties a door ID and a schedule ID together. In this example, access level ID 1 means door ID 1 can be accessed at any time because the schedule is set to always. Once the struct is ready, we call bs2 set access level to send the configuration to the device. For more details about this API, refer to the official documentation at the bottom of this page. Again, if you're familiar with BioStar 2, this will look very similar. On the left is the Add New Access Level screen in BioStar 2, where you select the door and schedule fields in the UI. On the right are the corresponding SDK structs. The bs2 access level struct holds the overall access level configuration, and within it, the bs2 door schedule struct ties a door ID and a schedule ID together. As before, filling out this form in BioStar 2 is equivalent to populating these structs in code. Now let's examine the bs2 set access level API. This API combines doors and schedules into a single access level. First, you create a bs2 door schedule struct, which pairs a door ID with a schedule ID. Then you place one or more of these pairs into the bs2 access level struct, which can contain multiple door and schedule mappings if needed. Once the struct is ready, you call bs2 set access level to send the configuration to the device. If the access level is created successfully, the API returns a success code. In short, you define the access rule and send it to the device. After that, the device knows which doors can be accessed and during what times. Now, we're on step 3, creating an access group. Remember, an access group is what connects users to access levels. But before we can assign users, we first need to create the access group configuration itself. On the left, you can see we have 3 access levels, each combining a door and a schedule. Access level ID 1, 2, and 3. These are bundled into a bs2 access group struct on the right. Inside, there are 2 key parts. First, the bs2 num of level union struct, which specifies how many access levels are included. In this case, 3. Second, the BS2 level union struct, which holds the actual access level IDs. Once the struct is ready, we call BS2 set access group to send this configuration to the device. For more details about this API, refer to the official documentation linked at the bottom. Once again, let's compare BioStar 2 with the SDK structs. On the left is the Add New Access Group screen in BioStar 2. You can see the access levels field where you add access levels such as Test 1 and Test 2. On the right are the corresponding SDK structs. The BS2 access group struct holds the access group configuration and includes a struct for access level information. Inside it, BS2 num of level union stores how many access levels are included, and BS2 level union holds the actual access level IDs. Just like before, the UI and the code are doing the same thing behind the scenes. Now, let's examine the BS2 Set Access Group API. This API configures an access group. However, what does that actually mean? An access group allows you to combine single or multiple access levels into a single access group ID. It can also support floor levels for elevator access. But in this session, we'll focus on doors. So why do we use access groups? Let's say you have a team of 50 employees who all need access to the same set of doors. Instead of managing each person's access individually, you create one access group with all the required access levels and assign that group to everyone. Now here's where it gets beneficial. Let's say the company adds a new meeting room and everyone on that team needs access to it. Without access groups, you would have to update each of the 50 users individually. However, with access groups, you add the new access level to the group once, and all 50 users are automatically granted access. The same idea applies when removing access. If someone leaves the team, you remove them from the group. If a door is decommissioned, you remove its access level from the group, and the permissions are updated consistently. So grouping permissions makes everything easier to manage, faster to update, and less prone to errors. As shown in the diagram, access level IDs are mapped to an access group, and then you call BS2 set access group to send this configuration to the device. Now let's set up the user's basic information. On the left, you can see the user profile, which includes details such as user ID, name, access period, and the assigned access group. It also shows the number of credentials, such as cards, fingerprints, and visual faces. These values are mapped into a BS2 user struct, which is contained within a BS2 user face EX blob struct on the right. You can see fields such as user ID, username, start time, and end time, which correspond directly to the information shown on the left. The num cards, num faces, and num fingers fields indicate how many credentials are registered for this user. Notice the access group ID field at the bottom. As mentioned earlier in the BioStar 2 Device SDK, the access group is created before the user. The access group ID generated in Step 3 is mapped to this field. By setting access group ID, the user is granted the access permissions defined by that access group. At this point, we're ready to add credentials to the user. Supported credentials include card, fingerprint, face or visual face, PIN, and barcode or QR code. The available credential types depend on the device's capabilities. In our code, we check which credential types the device supports before scanning. If a credential is not supported, the scan is skipped. In this webinar, we're using BioStation 3, so we scan a card and a visual face. On the left, you can see the credentials we want to register. These are scanned using the Suprema device shown in the middle, and the scanned data is then returned to the program. Once received, the data is stored in the BS2 user face EX blob struct on the right. You can see that num cards is now 1 and num faces is also 1, while num fingers remains 0 because we skipped fingerprint scanning. The actual credential data is stored in fields such as face EX objects for visual face templates and card objects for the card CSN value. For more details on scanning each credential type, refer to the official documentation. BS2 scan card for cards, BS2 scan fingerprint for fingerprints, and BS2 scan face EX for visual face credentials. Finally, we enroll the user on the device. Now we have a completed BS2 user face EX blob struct containing all user information and credentials. User ID 1001, one card, one visual face credential, the access group ID, and the credential data such as the face template and the card CSN value. Next, we call BS2 enroll user face EX to send this user data to the device. Once enrollment succeeds, the user is registered on the device. On the right, you can see user ID 1001 is now enrolled, and that's it. The user can now access doors based on the access group permissions we configured earlier. This completes the access control setup. We created a door, defined access levels, grouped them into an access group, and finally enrolled a user with credentials. From this point on, the system is ready. The user can authenticate and access the permitted doors. Let's compare the BioStar 2 UI with the SDK structs one more time. On the left is the user information screen in BioStar 2. You can view fields such as name, user ID, and group, and in the permission section, you assign the access group. At the bottom, there's a credential section for adding credentials. On the right are the corresponding SDK structs. The BS2 user face EX blob struct is a container that includes fields such as name, card objects, face EX objects, and access group ID. It also contains a BS2 user struct, which includes the user ID. Just like before, filling out the user form in BioStar 2 is equivalent to populating these structs in code. Now, let's examine the final API, BS2 enroll user face EX. This API registers a user on the device, including the user's credentials. On devices that support visual face, including FaceStation F2, BioStation 3, and BioEntry W3, the user data can include credentials such as card, fingerprint, visual face. Let's walk through the flow at the bottom. First, the user's basic information, such as user ID and username, is stored in the BS2 user struct in your program. Next, based on the order defined in your code, the program triggers credential scanning. Which credentials can be scanned depends on the device's capabilities. When the device scans a credential, the data is returned and populated into the corresponding fields in the BS2 user face EX blob struct. For example, face EX objects for visual face templates and card objects for card data. Finally, once the struct is complete with all user information and credentials, you call BS2 enroll user face EX to send everything to the device. And that's it. The user is now fully enrolled and ready to access the doors. So that covers basic access control using the BioStar 2 Device SDK. Now, let me show you a demo of the full end-to-end flow. In this demo, we'll go from creating a door to setting up access levels and access groups, and finally enrolling a user with credentials. Let's take a look. Now we authenticate using the card we scanned earlier. Note that the log timestamps are in UTC plus 0, while the device shows UTC plus 9. After the authentication, the door unlocks, and 3 seconds later, it automatically locks again, according to the door configuration. Now, we authenticate using the visual face we enrolled earlier. Note that the log timestamps are in UTC plus 0, while the device shows UTC plus 9. After the authentication, the door unlocks, and 3 seconds later, it automatically locks again, according to the door configuration. And that concludes the demo. Here are some frequently asked questions. The first question is, an auth mode error occurs. What does this mean? Suprema devices enable administrators to configure which credentials can be used on the device. If authentication is attempted with credentials that are not enabled in the device, an auth mode error will occur. For BioStation 3, you can configure the device's authentication modes using the BS2 setAuthConfig ext API. For more details and sample usage, please refer to the Config Control project in BSDemo. BioStation 3 supports various authentication modes, including visual face, card, ID, and combinations such as card plus PIN, ID plus visual face, and more. The next question is, what happens if a user is not assigned to any access group? If no door is configured on the device, the user can authenticate without any issue. However, once a door is configured on the device, the user must be assigned to an access group that includes that door to be granted access. Otherwise, access will be denied. The next question is, can I configure multiple access rules for the same user? Yes, there are 2 ways. First, add multiple access levels to one access group. Each access level can have its own schedule and doors. Second, assign multiple access groups to the same user. Each group can have a different set of access levels and schedules. Using these 2 methods, a single user can have multiple access rules. The last question is, how do I check which credentials the device supports? You can check which credentials are supported using the BS2 Simple Device Info and BS2 Simple Device Info EX structs. BS2 Simple Device Info contains fields that indicate whether each credential type is available on the device. BS2 Simple Device Info EX additionally provides information beyond BS2 Simple Device Info. This struct contains the supported field, which you can check using bit masking. For more details, please refer to the documentation links below. Thank you for joining today's webinar. I hope this helped clarify the access control flow using the BioStar 2 Device SDK.